Okay, looking at this question on exponential, let me underline some of the key information before we get started. So we have the value, which is the price of the car after t months. All right, this can be modeled by this particular exponential equation. And take note, k is a constant. The value of the car after 12 months is expected to be 40,000. I will need to find the initial value of the car. Recall, when you see this word called initial, means at the very start. At the very start, it means that the number of months will be t is equal to 0. Let me try that into the equation. So when t is equal to 0, but exponential is subjected to 0, this means at the very start, the price of the car is 50,000. Alright? So this word called initial is very important. It means that no time has started, it's at the very beginning. Take note, before we can actually calculate the car value after 20 months, alright, in this particular equation, we wouldn't know what is the value of k. So let us use the important information that after 12 months is 40,000 to find the value of k. 12 months means t will be equal to 12. 40,000 means v will be equal to 40,000. Let me put it into the equation. So we managed to form an equation. So our job now is to solve for the constant k. Divide both sides by 50,000. It seems that we have a logarithmic equation that we can do in order for us to deal and solve. Alright, I will have to introduce ln on both sides. Using the power law on the right hand side, this can be written as negative 12k because ln e is equal to 1. Now find the value of k, and remember I will only press my calculator at the final step. I will write a more suitable and more accurate answer for k. Instead of 3SF, I can use 5SF, and you can even store it as a memory in your calculator. Let me put my value of k back into the original equation. Remember, in part 2, I will need to find the value of the car after 20 months. This means that my value of t is equal to 20. Substitute it into the equation. After that, I can press the calculator. And if the answers are not exact, since this is in money, you may want to estimate to 2dp. And then we'll have our answer in 2dp, which is the value of the car after 20 months, before we come to the last part. So in part 3, we were told that the value of the car actually dropped below $20,000 after n months. Let me write the information out. So this means in part 3, the value of the car is 20,000 when the number of months is actually n, and take note, n is an integer. Let me use the equation that we found just now to see whether we can find the timing required. By substituting inside this equation to solve again, so our job is to solve normal exponential equation, and take note, n must be an integer. Divide both sides by 50,000, so the coefficient of e will be 1. Next, I will introduce ln on both sides. After that, I will make use of the power law, since ln e is equal to 1. Alright, then I'll divide both sides by the coefficient of n over here. I'm mindful I have actually stored the value in my calculator just now, so it's actually quite easy for me to press the calculator. Note, this is a contextual question, so do not just round off easily. Okay, the question specifically say it must drop below 20,000 after n months. If I round off my answer to 49 months, it will not drop to below 20,000 yet. Alright, but after 50 months, it will drop to below 20,000. So in this case, I must estimate my n as an integer 50. I have to round up because if I round down, it will never drop to below 20,000.